Welcome everyone to today's Virtual Connect on 2018 IECC requirements for commercial projects. You will receive 1 HSW credit for attending today. Please use the Q&A function that you'll find at the bottom of your screen, and we will get your questions at the end of the presentation. And so without any further ado, I'll just go ahead and introduce our speaker today, who is Hope Medina. Hope is an energy and green code consultant for Colorado Code Consulting. She holds several International Code Council IECC certificates that she utilizes as a plan analyst, inspector, and instructor. Hope is very active in the code development process, regularly attending the International Code Council's code development hearings to participate in improving the various building codes, and is co-chair of the Colorado chapter of IECC Code Development Committee for the Green Codes and Standards. So without further ado, I'll just go ahead and turn it over to you, Hope, and I'll be in the background and enjoying the presentation. Thanks again.
All right. Well, welcome everyone. As it was said earlier, we're going to talk about some of the commercial energy requirements that you're going to find for the 2018 IECC, with a little bit of foreshadowing of some 2021 provisions that I really feel you're going to want to be aware of that are up and coming. So the thought process behind the information that I'm giving you today is obviously there's an awful lot of provisions within the energy code, and we're obviously not going to be able to get through all of this in about an hour, right? So I decided to focus on those elements that would be most important, or something that as architects you're going to want to focus on. And then out of those, I wanted to get and really hit upon what we consider the heavy hitters. What's going to be the most impactful when it comes to you know, energy efficiency. Now you say, oh, how in the world would you ever know what the heavy hitters are? And so back during the 2009 IECC, Colorado Code Consulting, along with other stakeholders, we did a study to figure out which provisions actually made the biggest impact when it came to energy efficiency. Now, we took that information and we utilized it, you know, so that if you're going to do one thing, do this, or if you're going to do two things, do these. Well, when the 2015 IECC came about, we went and performed another study to update them to see where things are. Now, there hasn't been a study that's been done for the 2018, but what I did take were those consistent heavy hitters, and we're going to talk about those today. And I want to make sure that you know, that the contractors build, you know, what you're trying to design, right? Because that's the whole intent of it, giving out the information so that the contractors can build, you know, these projects that you design. The building department understands what you're trying to you know, have done with these designs. So let's go ahead and, you know, get going on that. Oops. There we go. You already saw I'm a code geek. I enjoy talking about codes, and especially those odd codes like the energy code and the green code. So one thing I want you to keep in mind is the energy code really tries to get you to where you need to go. They try to create a pathway for you to get there. And so for that to happen, you have to make a decision as far as which energy compliance path you want to utilize for this project, because so many things are gonna depend on what your choices are as far as the energy compliance path. Now you have a few options. You have your true prescriptive, you have your components alternative, and then you also have your performance path. And then you have the option that if you utilize ASHRAE 90.1, the 2016 version, then you are deemed to comply with the 2018. Now, why is this so important? Because you as the architect, are kind of the gatekeepers to these projects, right? You have to help facilitate the owner's dream or desire of what these buildings are going to be. But in doing so, you also have to somehow juggle the, you know, other people that are involved, your engineers, you know, working on the MEPs, you know, your soils guy, everybody that's involved with the project. You're kind of that gatekeeper. So you juggle that aspect of it, and you have to juggle to make sure that whatever it is that the owner's desire is for this building, you can get it built under what the codes are, whether it's the building code, the energy code, whatever the case may be. You have this fantastic role when these projects are being presented. Now, with that being said, you also have to understand and make a decision as far as what you want your path to be. Now, often I write up review comments just about to almost all my projects that I review for energy code compliance, and I have to ask them, what energy compliance path have you chosen? Now, some would say, well, if I don't say anything, then I've obviously gone prescriptive. And as we'll start talking about it, you'll see where all the questions for me come in as a plan reviewer. And I can't even imagine what it would be, you know, on the other end for contractors when they're out there and they're not sure what they're doing, because what they see on the plans doesn't necessarily correlate with, you know, going with the prescriptive path. But knowing what your path is so important that in the 2021 IECC, it is actually required that you will have to declare what energy compliance path you have designed this project to, and it will have to be placed on the construction documents, not in a project manual or in some other location. It actually has to be placed on those construction documents. So what are your options? Like I said, you have prescriptive, you have your component performance alternative, your total building performance, and your ASHRAE 90.1. Whatever you choose, you know what, it's perfectly acceptable, and you just need to make sure that you follow it all the way through. And that's especially important when you, if you decide to go with ASHRAE 90.1. Sometimes that'll be driven by how the mechanical systems are designed. Sometimes it's better for the mechanical systems if they utilize ASHRAE 90.1 as opposed to the IECC. So if that's the case, just make sure everything is utilizing 90.1. That means your thermal envelope, your mechanical, your electrical, your service water heating, everything will have to comply with it. So like I said, the IECC really tries to give you everything that you need to be able to get this project through to fruition. So in that, they give you this roadmap. They give you 12 items right here that you're going to find in Chapter 1, and it lists all the things that are supposed to be placed on the construction documents to help not only you, helps the contractor, helps the building department, helps the inspector, helps everyone involved with this project to make sure that we're all on the same page. Now, if you'll notice, when it comes to components that, you know, typically would be responsible by, you know, the architect, it's going to be your insulation materials and R values. Now, often I may see something on the plans that'll say it's going to be an R20 in the walls, but they don't tell me what the insulation material is. And that can be, you know, a pretty important factor to know, especially when you start dealing with, you know, fire rated construction or the type of construction that's involved. There's a lot of things that can come into play with it. And so this becomes one of those areas that if you provide this information up front, then we can cut out a whole bunch of review comments that may come into play. So the other one is talking about your fenestration U factor and solar heat gain coefficient. And then your area weighted average. And then last but not least is your air sealing details. That is going to be so important, and we'll discuss that in quite a bit of depth here shortly as to why this is so important. Now, this may be a section of the energy code that you might not be as familiar with as you have been with other provisions that you've seen in the past. It's not that uncommon, and I have to say that quite often for a while there, code officials were not very familiar with this particular section of the code, that this tool was there to assist them and to assist everyone involved with the project. It's so important that you are going to see in the 2021 where there's going to be some additional items that are going to be placed in there to, you know, help facilitate so everybody can get to the energy compliance that we're all trying to get. There we go. Another one is your thermal envelope. I cannot tell you how many times I have to call this out. And you would think that, you know, I've actually had responses back from architects when I've made the comment, you know, please define your thermal envelope. I should be able to take my finger and trace it without lifting it. And I've had responses that come back and say, well, it's all the exterior walls, and which would be fine. You know, by code, you have to show it on the plans, and it's been in there since the 2015, and many jurisdictions actually amended it to be into the 2012 editions of the IECC. But there are some other provisions that kind of come into play with it. I don't know if you're aware of, but mechanical rooms, if there is mechanical equipment in these particular rooms and they have outside combustion air that's being brought into these rooms, then there's a few things you have to do. You know, you may have to thermally isolate the room, or you have to have it located outside of the thermal envelope. So knowing exactly where that thermal envelope sits becomes important, or what, you know, having that in there. And one of the tips that I'll tell you, because often on that back wall, that's where the mechanical room is located, or in the corner, or what have you, put a little note. It says mechanical room, and then under it say no combustion air. That will do wonders for you in plan review, I'm going to tell you. So as we stated earlier, you know, tell me what you're putting in for your thermal envelope. Tell me what the values are, make sure that they're in the correct location, and show me what type of materials that you're utilizing. So this is the table that all of the compliance paths and so many provisions that you're going to find within the energy code. And basically, you know, this is your jumping off point right after you figure out which compliance path you're going to use. But to understand this table, we need to understand how it's set up. And so the first thing you're going to notice is everything is determined by the climate zone. Which column you look at, how you're going to deal with things, do you fall in under exceptions? Everything is done by the climate zone. So to figure out how to get to the correct climate zone, you're going to go into chapter 3. And in chapter 3, there's this ever so lovely, you know, picture here, image. Of course, in the book, it is not colorful. It's black and white and gray, so it makes it ever so lovely to figure out whether you're a 5, a 4, a 3, or a 2. And if you notice on the map, most states have multiple different climate zones in there. I think California has the most with 5, because Colorado has 4. But unless you're like Kentucky or Massachusetts, who only has 1, looking at this particular map isn't going to really be able to get you to what exact climate zone you are. So then what you're going to do is flip the page over, find the state, and figure out which county this particular city is located in. So if it was Alamosa, Alamosa County, you know that they're going to be a 6B. So now you know you're going to be looking into the 6th column. So again, we have our climate zones. And then our climate zones are broken up into 2 more columns. We have our group R column, which is all your R occupancies, you know, R1, R2, R3s, R4s. And then you have all other. So now you know you're in climate zone 1, it's going to be in R2. So this is going to be the column that you're going to have to take a look at. And then it's broken up into very specific categories. So you have your roofs, you have your walls above grade, walls below grade, slab on grade, and opaque doors. And then it goes into even further information that starts to deal with the specific types of components that are in this type of category. So if we took a look at the roof category, entirely above deck for a climate zone 5, you're going to be dealing with that your minimum is an R30 continuous insulation. Now, one thing I want to, want you to keep in mind, if you do choose to go prescriptive, and there's absolutely nothing wrong with going prescriptive, you have to do everything that's listed in this table, and these are the minimum requirements for it. So that means, things where, slab on grade, you can't trade off slab on grade if you're going prescriptive. So just keep that in mind when you are thinking about what type of energy compliance path really makes sense for your particular project. All right, now we're going to run into some of the actual provisions and, what's the big hitter about it and what's the big deal about them. So the first one we're going to talk about is our above grade wall insulation. I think everybody probably thinks about, the pink in the wall and knows what it is. But there is a lot of things that can be involved with it. You're going to want to make sure that you have your insulation values again on your plans and what type of insulation that you're going to use, and make sure that it correlates with whatever compliance path you have. Now, all this information is going to need to be provided to your mechanical contractor or your mechanical engineer, because they're designing the mechanical systems to the values that you have within your thermal envelope. And so this is where it makes a big difference. It's not the actual insulation in the walls that saves the energy. It's part of the process for it. It's the mechanical work that's going to save the energy, right? So if that mechanical equipment is sized appropriately, because there's actually a good thermal envelope involved, this is where you're going to start to see those energy efficiency components come in. And this is why it's so important that the actual thermal envelope values not only are placed on the plans, but it's passed along to all the various entities that are involved with it, because this can make or break the type of mechanical system that's going to go into particular projects. And you have to remember too, this information becomes very important, especially when you start talking about fire rated construction. So let's talk about and look at what's involved when it comes to the above grade walls. Now the table that you see on the top of the screen, that comes out of the R value table. The values that you see on the bottom is your U factor alternative approach to it, meaning that you're going to utilize the entire assembly to get to that U value and not just utilizing the insulation that's in the walls. So if you happen to notice, if you look at the table at the top of the screen, they all say an R13, and then it says, let's go to the very first column. It says an R5.7 CI. Now CI means continuous insulation for these mass walls. If you go to the metal building, it says an R13 plus an R6.5 continuous insulation. If you happen to notice, all of the above grade wall types are required to have a continuous insulation involved with it. So if you go truly prescriptive, you are going to be required to utilize that continuous insulation requirement for your wall assemblies. Now there are a couple of options where it does allow for an R20 cavity, and I believe that those will be removed when it comes to the 2021. But as you can see here, I wanted to give you an example. If you, on the right-hand side, you'll see a, very typical comm check, gives you the information as far as, what you're putting into your thermal envelope. And then it correlates over here on the left-hand side to what the mechanical contractor put in when they were doing their mechanical load calculations. And that determines the size of equipment that they're going to install for the particular project. Now, I mentioned to you earlier about fire rated construction and the thermal envelope. And the importance of this is, a lot of times, and a lot of people think that if it happens to be construction that's dealing with fire rated walls or fire rated assemblies, whatever the case may be, that the energy code loses out, that supersedes the energy code. And yes, life safety, the energy code is not allowed to, abridge life safety, but that doesn't mean that there's a complete exemption or a complete doing away with anything that you can do when it comes to fire rated construction. If you noticed, on most listing, a lot of the listings for the fire rating, it has in there to utilize like a minimum R13 bat insulation or something along those lines. There's usually a minimum of 3.5 inches or whatever the case may be. You can incorporate that into your thermal envelope and you can still utilize it. You can go in there and say, it says a minimum of R13, so you decide we're going to put an R20 in the wall. Well, that's great, but if you don't put it on your plans that wall is going to have an R20 in it, in your sections or wherever you're going to place your information, what ends up happening is, the contractors, they look at it, they look at the listing to make sure that the listing information is correct, and it says an R13, you have nothing placed on your particular plans that say it's going to be an R20. What do you think the contractor puts in? They're going to put in an R13 because that's what the fire rated construction listing states. It's a minimum of an R13. It says R13 there. There's nothing on the plan, so I'm assuming we're going with an R13. Now, if you remember previously, in the previous slide, the mechanical contractor did their mechanical load calculations for an R19. So now they may have sized their equipment incorrectly and it won't actually perform the way that it's supposed to perform, and it won't heat the building as it should. Just by one little, omission can cause some, snowball effects from it. Roof insulation is a really big heavy hitter because, if you think about it, it either keeps the heat in or keeps the heat out. It is a really big, important heavy hitter. And so you need to know what it is that you're going to be utilizing. So are you doing entirely above deck? Is this going to be a metal building? Are you putting it in the attic, very typical to what you would see, for residential applications. Whatever it is, this information needs to be placed in there. Now, roof insulation, it has to be, has to meet the minimum values that you're going to find in there. And if you're utilizing, multiple layers, you need to make sure that those layers, that the joints and seams are staggered so that there isn't that heat loss always at that same line. And you need to keep in mind that insulation that's placed on top of suspended ceiling tiles, they're not going to be considered part of the thermal envelope. Now you can have them there. There's nothing wrong with having them there. And quite often they get placed there, especially if it happens to be above a restroom, because nobody in that office next door wants to hear the toilet flushing over and over again. So, that's not unheard of, but just realize that that's not going to be part of your, or, be considered part of your thermal envelope. And keep in mind too, if you are going prescriptive and it's for a metal building, there are a few additional things that you're going to have to keep in mind. You are going to have to utilize a liner system. And you're also going to have to utilize thermal blocks, and that information is going to need to be placed on the plan so that everybody is fully aware of it. And skylights, since we're already in the roof area, let's go ahead and take a look at skylights, right? So skylights changed that it is now required if the room directly under it has a ceiling height of 15 feet and it's at least 75% of that area, and that area happens to be 2,500 square feet, you're going to be required to have skylights in it. So the occupancies that you're going to be wanting to install these are going to be offices, lobbies, atriums, you know, the whole gambit list that you see up there. Excuse me. So that's something to be aware of. And this is probably one of those areas that I see quite often and have many discussions on is your slab on grade insulation. You know, if you are going prescriptive, then you are going to be required to install a slab on grade insulation. And quite often on the image on the left-hand side, that's what I see. It starts at the bottom of the slab and goes down to the footing. But that's not how the installation requirements actually go in. You have to start from the top of the slab and extend down to the accepted distance or to the top of the footing, or your other choice is to start at the top of the slab, go down to the bottom of the slab, and then go horizontally for the remaining of the distance. But those are the ways that it needs to be installed. Or you can place it on the outside of your foundation and place it there also. Now, one of the questions that I get when it comes to that is, well, you know, I can't, there's, you know, a concern about placing the insulation between the slab and the foundation wall. And if you go and you look at, you know, soils report, or sometimes they have it in on the structural plans themselves, it'll say that there needs to be a control joint. And I've referred to it as, you know, I've talked to some engineers and they've said, yeah, you can totally use that as your control joint in those locations. Of course, I'm, you know, not advocating or superseding what your engineer is saying, but I have spoken to a few and they've said that, you know, in these types of situations, it's perfectly acceptable to utilize that. So keep that in mind. Fenestration. Glazing is a huge factor when it comes to energy efficiency. And there's a lot of things that kind of wrap around when it comes to the fenestration requirements. So if you look at the table here, and this is C402.4, it gives you a lot of information. Again, we're dealing with that whole climate zone deal that's going to determine it, but it gives us our U factor requirements depending on the type of glazing, you know, whether it's fixed, operable, it's an entrance door. And then we have our solar heat gain coefficient, which is, you know, really important. And there's so many factors that are actually going to be determined with it. So the location of where these windows are placed in the building and they're facing is going to determine your solar heat gain coefficient requirement. So orientation is going to matter, and you need to make sure that that ever so lovely north arrow that's required by code to be placed on there is there so that everybody's able to determine it. And then it's your projection factor that's also going to come into play with it. So if you have a projection factor of 0.2 and it's facing north, you know, for climate zone 4, your maximum is going to be a 0.48. So these are things that are going to be important. And what I can tell you is code officials are a lot more aware of the projection factor issue and making sure that they're getting the correct information as far as what the solar heat gain coefficient will be. Now I've seen where they take the most restrictive, you know, we'll say for climate zone 4, the most restrictive is going to be the 0.36. So I've seen where it placed on the plans where it says the maximum solar heat gain coefficient for any window is going to be a 0.36. And even though it's not very specific, at least I know that we're not going over that. But just so that everybody is completely aware of how to determine the projection factor, you're going to take the bottom of the glazing to the underside of the projection or the overhang, and then you're going to take from the face of the glazing out to the edge of it. And the horizontal is then divided by the vertical. And so that's going to give you your number. So if A happens to be 30 inches and then B happens to be 84 inches, we're looking at a projection factor of a 0.36. Now, like I said, because code officials are more aware of this because of all the training that has happened in the last 6 months with our lovely situation of dealing with COVID, don't be surprised if you get asked about what your projection factor is for some of your glazing. That may be something that comes up. And another thing to be aware of is when you're submitting plans, providing the NFRC labels so that they can determine whether or not, you know, the framing and everything is going to be within code parameters. The other item that you need to make sure is about your glazing leakage. This happens to be one of my biggest pet peeves, and some of my local restaurants know me quite well and know not to place me at a window because their air leakage is so crazy that there's no reason that I should be sitting there and the blinds are moving from the amount of air that's coming in from just the air leakage. So please be aware that you need to, you know, have this. And the question becomes, whoops, sorry about that. The question becomes, do you place this on the plans or do you place this in the spec book? Now, you know, a lot of times I hear a lot about, well, I place that information in the spec book, and there may not be anything wrong with that. What I find in the spec book often is just a lot of boilerplate information. It's not even necessarily specific to the, you know, to the project. And what I find often that I have to call out is because it hasn't been, they probably don't get looked at and updated often, that the information that's in there, like for your piping insulation, goes back to like the 2009 requirements and is not to the 18 requirements, you know, that was changed. Or there's a few other things that I've noticed in there, you know, consistently that hasn't been updated with it. So you may want to, you know, make sure when you start talking about, you know, the piping insulation or the thermal dynamics, whatever the case may be, that it is updated to the latest code cycle for it. Now, this isn't necessarily a, you know, thermal envelope ordeal per se, in the sense that it's not something that you would necessarily oversee, but it's located in the IECC in the section for the thermal envelope, and then it's also placed again into the mechanical section. In the mechanical section, it does provide a little bit more requirements as far as, you know, you need to make sure that it's motorized unless it falls under these particular exceptions. But it is also placed on the thermal envelope side because it happens to be a penetration in that thermal envelope. And so we want to make sure that if you are, you know, doing a really good thermal envelope and doing everything you can, you don't ruin it by leaving this hole that isn't protected correctly. So just keep that in mind. I have had a couple of times where, you know, the dampers actually hadn't been provided on the plans by either the architect or the mechanical engineer. Just, you know, something that was overlooked. Air leakage. Now, earlier in this webinar, I said, we'll get into this a little bit in more detail here, and here's where we're gonna go. So when it comes to air leakage, you again have a lot of options. You can either utilize the quote unquote prescriptive path, where it tells you do this, 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 and this, and you have some options even within that. Or you can do basically a blower door test for your project. You can do one or the other, and it doesn't matter. You have those options. The only thing I'm going to say is, really be aware that the air barrier really cannot be an afterthought, and make sure that everybody is on the same page when it comes to that too. And this is one of those times that you may not want to just place it into a spec book as far as what you're going to do. Call it out on your code analysis. Have an energy code analysis that provides some of the information on it. I'll talk about that a little bit later, but provide that information that says, hey, we've chosen that we're going to do a blower door test for those particular areas that still allow you to have the choice. Whatever it is, you need to make it quite clear, because here comes a situation where it wasn't expressed really well, and it became a problem out in the field. So in this jurisdiction, this particular inspector had done the plan review for this project and happened to know and was really excited about the fact that they had chosen to do the air leakage testing as opposed to doing the prescriptive path for the air barrier section. And so she was looking forward to it. She happens to like energy like me, so she's a energy code geek too. But she knew it, and she was getting close towards finals, and she hadn't seen anything, hadn't heard anything, and so she asked, when are you gonna do your air barrier testing? And the super was just, kind of, what are you talking about? And it's like, well, in your spec book, it states that this project's gonna do the air leakage testing. And so this became a big deal because, with that miscommunication that had happened, with that information being placed in the spec book. Now, of course, you could say they should have read the spec book, and I don't disagree with that at all. The contractor was under the impression that, when they came out to do the sheathing inspection, that they checked the air barrier, because that's what he was thinking that they were utilizing. The inspector, knowing that they were being tested, that they had chosen the test, obviously she was looking at sheathing. She was looking at the sheathing for other parameters, because they weren't doing the prescriptive path for it. So those items aren't something that they would necessarily look at, because the choice was to go with the air barrier testing. So then there was a lot of things that happened. There was a lot of miscommunication. There was a lot of, what are we going to do? A lot of phone calls that went around, and a lot of discussion. So, I just, save yourself from having to do that. Just make sure that information is placed. So air barriers have to be, continuous, and they're required for all the climate zones except for 2B. Don't ask me why. I don't know why 2B is so special, but it doesn't have to have a continuous air barrier. But the air barriers can be located inside the thermal envelope, outside the thermal envelope, or they can be a combination of the two. Now, they need to be a continuous for the entire assembly of the thermal envelope, because they work together, because the insulation is your thermal, and the air barrier keeps the air from coming in and removing that, because when there's air movement that comes in and passes through the insulation, that actually takes the R value away. You're also going to need to make sure that all the air barrier joints and seams have been sealed, and that they're able to deal with the different types of materials that are going to be utilized. This is probably one of the areas that I do, make comments on. What are you doing? What are you going to utilize? Tell me what your air barrier system is going to be, and tell me how you're going to seal your joints and seams, because often they'll say, well, I'm going to use my sheathing. That is perfectly okay. It's perfectly acceptable. Use your sheathing, but how are you going to seal it? Because all those joints and seams will still have to be sealed. And so, those are little details that, you're going to want to keep in mind. Recessed lighting has to be IC rated and gasketed if they're located in the thermal envelope. I think that's almost a gimme nowadays. It's really difficult to find recessed lighting fixtures that aren't IC rated. I mean, usually they have that little sticker on there now that says energy code compliant or IECC compliant. The electrical manufacturer industry really took the energy code and ran with it and made it really easy for all of us to comply with it. The other thing is, keeping in mind is, all the penetrations that are going to go through that air barrier, right? Because no matter how you design it and how perfectly you do with it, there's always going to be something that happens out in the field. Oh, we have to move that pipe. It has to go through here. The inspector came out and said, oh, nope, that opening happens to be too close to that window. It has to have a 3-foot distance. You're only at a 2-foot distance. You're going to have to move it. Whatever the case may be, there's always going to be something that comes up. So provide them with that contingency plan. Okay, you're going to do this. Okay, this is how you're going to address any penetrations that happen within that thermal envelope. And something you got to keep in mind with too is sprinklers. So if you have to deal with sprinklers and they happen to be concealed sprinklers, you're going to need to provide the manufacturer's installation instructions on how they're going to be installed that meet the air barrier requirements. Each manufacturer is supposed to be providing that information on how to address it. That's all the information that I can give with you with it, but they're not supposed to be sealed. And code officials are more aware of this and contractors are more aware of this. So I wouldn't be surprised if you get asked, to provide this information. So you have two options as far as how you can comply on the prescriptive side of, the air barriers. You can either utilize the material or, you can utilize the material. And one of the things that I want you to keep in mind is, as you see, you can use, single ply roofing, you've got OSB, you've got plywood, you've got drywall, the whole 9 yards. The one thing that's not on that list is house wrap. House wrap was designed and intended to be a water resistive barrier or a weather resistive barrier. It was not necessarily intended for air barrier applications. Now there are water resistive materials that have been listed and labeled to also be air barrier materials. But what you're going to need to do if you say, hey, we're using Tyvek, we're using this type of Tyvek, which happens to be, can be utilized for both if you install it per the manufacturer's installation instructions, and you provide those instructions, and it would be absolutely perfect if you place that little paragraph, because it's not big as far as how it has to be installed, and you placed it on the plan. So there is no question on how that air barrier system needs to be installed for that Tyvek wrap. Now the other option you have is if you were to utilize an assembly. Now, why are air barriers so important? And the reason is because there's a lot that is going around with that. In the 2021, there are requirements that are coming in that there's going to be a building envelope performance verification. And in that verification, there's going to be a third party that comes out and verifies that the insulation was installed correctly and that there was an air barrier. Because remember, when it comes to building thermal envelope, it's not just the pink in the walls, it's the whole system as a whole. And so that's going to be a requirement. It is still at this point a visual inspection, but it is required to happen. And there's commissioning reports that are going to be required for it when it comes to the 2021. Now, I said that it's the 2021, but what I will tell you is there are quite a few jurisdictions here in Colorado that are taking that provision for the building thermal envelope verification, and they're bringing it into their adoption for the 2018 IECC. So it has the 2018 stuff, but they're bringing some things in from the 2021. So, I believe Denver has done it, Fort Collins, I want to say Boulder, but there's quite a few that are already requiring it, and quite a few others that are looking at it to start requiring it when they do their 2018 adoption. So keep that in mind. You're going to have to be more cognizant of providing that information on the plans. And then the other thing is the air barrier testing. If you remember when we started talking about the air barrier section, I said you had your option. You can either go with a prescriptive path, or you can have it tested and do a blower door test. That option goes away in the 2021. In the 2021, it will be mandatory that you utilize the testing portion. It will be required that you do it. You're going to want to do everything else as far as the prescriptive, because if you don't do that, you will never pass the air barrier testing that's going to happen. And when you don't pass, it's not that they're necessarily going to fall onto, you know, they're going to go to the contractors, they're going to go to you guys, right? So let's just alleviate that altogether. And another thing to keep in mind, there are a lot of jurisdictions, again, who are taking those 2021 requirements and bringing them into their 2018 adoption. So, you know, again, Fort Collins, Denver, Summit County, I want to say, they brought that in as a requirement to their 2018 adoption, and they're already requiring it. It's already been adopted, it's being enforced, so keep that in mind. The air barriers can no longer be, you know, that afterthought. You're going to have to think it out and be very explicit as far as how you want it done. And one of the things that I think would be, you know, just absolutely, you know, to your advantage is if you created a quote unquote energy page. You know, you create, you know, fire resistor rating pages, you create accessibility pages, and it really helps to alleviate, you know, some of the questions and concerns, you know, code officials and contractors have when it comes to those particular areas. So why not, you know, do something like that to help assist you when it comes to the energy efficiency? I know if you go performance, I get a little index if a project goes performance, and I'm talking commercial. I've had quite a few commercial projects that go performance, and depending on who does it, but there's one particular company that always provides, it's like this index, and it says, oh, okay, your thermal envelope components can be here, your wall, whatever the case may be, they give you, and then they give you the sheet page of where it's at, and you can go back and forth. And I cannot tell you how much of a breeze that is to, you know, do a plan review for, or as an inspector, I can look at that and say, oh my gosh, this is great. Okay, so I look at page 3, it's right there on the wall, we're good to go. You know, and it also is a you know, a huge, you know, benefit for the contractor. They don't have to go looking through everything. They know exactly where it is, where they need to find that particular information. So I believe that Denver already requires something like that. And I believe there's a couple other places that are looking at something like that. There was a code proposal for the 2021 for that to go in. It didn't make it, but there are people that are looking at that, and it will probably go into the 2024 IECC. So keep that in mind. Now, how many of you knew that there were energy requirements when it comes to elevator cabs? And I'll have to tell you that there were a lot of code officials that were not familiar that elevator cabs, you know, had energy code requirements, but there are. And so you might want to make sure that when you say you're going to put in an elevator, just make sure that, you know, these requirements have been met, that the cabs have this information. Most manufacturers can give that to you, not a problem. And another one is swimming pools. Swimming pools and spas have energy code requirements. There's requirements for the heaters. There's requirements for time switches, covers. That's probably more in the area that you would be involved with, would maybe be the covers. And so just keep that in mind if a pool or spas are coming in, since you are kind of the gatekeeper of the project. Say, hey, what are you doing to meet the energy code? Might be a nice little catch it now instead of getting a review comment for it. Another one is for the I codes. All the appendices do not apply unless they are adopted. So keep that in mind, but you can always use an appendice if you're going to use it as an alternative method, and it becomes a great backing point for you when you say, hey, I want to do this and I would like to utilize, we'll just do this one, Appendices Ca, and this is why. So just keep that in mind when you're doing alternative materials, that there are a lot of things that are going to be able to assist you with that, and utilizing appendices that already exist is a good one. But Appendix Ca happens to be the solar ready zones. Solar is, a big, hit word, I guess. I don't know what you want to call it, but there's a lot of solar provisions that are going around. And if you had the chance to listen to the energy code hearings, you probably got to hear an awful lot about solar, whether it should be in the energy code, shouldn't be in the energy code, the whole 9 yards. But this is in the energy code. It's in the 2018. And I can tell you that there are jurisdictions that did adopt the 2018, which included utilizing Appendix Ca. So there are jurisdictions out there in Colorado that are already requiring this. So there are a few things. You're going to have to demonstrate where your solar ready zones, and you're going to need to provide all the documentation for that. And so that's going to be required for if you are a building that's 5 stories or less in height and you're orientated within those particular degrees, and you have a low slope roof, which many commercial projects do. Most of them are probably, more that flat roof type. So you're going to need to designate where this solar ready zone is, and it needs to be not less than 40% of the gross roof area. But that doesn't include things like skylights, or if you have a vegetative roof. You don't have to have a single area. You can do sub areas. And you just need to make sure wherever those areas are, they have to be free of obstructions, meaning, this is information you're going to need to relay to the mechanical guy and to the plumbing engineer. Because they're going to need to make sure that they don't have any vents or any pipes or any exhaust ducts. None of that is going to be located in these quote unquote solar ready zones. Those are free of anything. You're also going to want to make sure that the roof has been designed for that additional load that's on there, and they call out for 5 pounds per square foot. You're going to need to make sure that there's a pathway for routing the conduit, and that there's a space within the electrical service. Now, this is where, a lot of it is going to be, where you're going to need to make sure that this information is placed, on the plans. You're going to need to make sure that it's very defined on the plans where that solar ready zone is going to be located. You're going to need to make sure that, the conduit, pathway is going to be there for them, so that there are no questions if they do decide to install the solar, especially when you're dealing with locations like, I'll say it again, Denver, that has the green roof initiative that went into play. And one of the options to, deemed to comply with it would be to utilize solar. So this may be something that is going to be probably a little bit more prevalent in Denver, but it is going to be utilized. There's a lot of communities right now that are talking about that they want to be, 100% electrification. So there's a lot of that going on. And, one of the ways that you're going to be able to get to that is utilizing solar. And so they are recognizing it. And so they may not adopt some of the other things, and their idea for electrification may be, down the road, 2040, 2050, even 2030, but to do that, they realize that these buildings are going to have that capability. And so to do that, you're going to have to make them solar ready. Just keep in mind that if you do go with the prescriptive path, you are going to be required to provide an additional efficiency package. Just make sure if that's if you choose to say like you're going to do reduced lighting power density, which is the easiest one to do, just make sure that everybody is on the same page so that, you know, when we receive a report, because they are required to give us a ComCheck mechanical and interior lighting compliance. Those are the easiest reports to provide for the requirements because they can just print them out, put it in, print it out, give it to us. Everybody's good with it. Everybody knows how to read it. But just make sure that everybody's on the same page and says, yes, we're going to do reduced lighting power density, because there's nothing worse than having the runaround where, you know, you've chosen to do, I don't know, enhanced lighting controls, and they chose to do power to reduce the power density. And the mechanical guy says, no, we're going to do more efficient HVAC equipment. I don't care what it is. Just pick one, make sure everything stays the same. And so that, you know, there's no question about what's going to happen. So like I said, you know, my thought is just make sure everybody and everything is on the same page. Make it as easy as possible for everybody to be able to get what you designed into reality and out there and working and functioning as you had envisioned for it to happen. So if you have any questions, I'm always happy to answer anything. If you think of something after everything is said and done, here's my contact information. And that's all I have.
Thank you, Hope. That was terrific. You must have just answered any questions anyone could possibly have, because the Q&A is empty right now. But thank you so much. You did a great job presenting.
Well, thank you very much for having me. I appreciate it.
We actually just got one question from Margaret Blakely, who asked if you could touch on the fire sprinklers again.
Okay, so fire sprinklers, because if they are part of a concealed, if they're concealed fire sprinklers and it happens to be within the thermal envelope area, what you're going to need to do is the manufacturers should have instructions for you and for everyone involved that tell you how they want it addressed, whether it's, okay, so you're going to tent these, those that are within the thermal envelope, or, you know, we're utilizing this, whatever the case may be, but they have to tell you how they want their specific product to be utilized. Because what was happening is they were going in, and then contractors, knowing that, you know, that they're doing their due diligence, want to make sure that, you know, they're not leaving any air leakage within the thermal envelope, and they were going and sealing them up. Well, that voids them and they don't function properly. And so we actually, I was part of NFSA, National Fire Sprinkler Association, working with them because they wanted to exempt them completely. And I said, no, because they'll never pass any testing if they have 400 holes in their thermal envelope. And so, you know, we worked together, came up with this great compromise. And so now manufacturers, because code officials are asking for it and you all are asking for it, they are providing that information for you. I hope that answers it.
She says, thank you, very informative. Jennifer Ramsey just asked, are there any upcoming changes impacting existing retrofit or historical buildings?
So for the IECC back in the 2015, there was the new chapter that was created, which is Chapter 5, and that just deals with how to deal with our existing building stock and our historical buildings. There isn't necessarily anything that happened from the 2018 to the 2021 as far as that goes, but I can tell you that the 2024 will have some proposals that are going to be submitted to help kind of flush out and work on Chapter 5. One of the thought processes are to kind of create it, make it more compatible or more in the format of what you find in the international existing building code, where it has the different levels. I know that Denver did kind of create their own existing building kind of code that kind of dealt somewhat in that fashion, but that is something that we are looking at to address. Was there anything specific when it came to existing buildings or historic buildings that the concern is?
I'll see if Jennifer types something in.
Okay.
Or if I can actually allow her to talk if she'd like. It's hard to, let's see. Well,
hey, Hope, I was just part of a project that was historical for part of it and then not historical for the rest. And so sort of navigating those two was pretty difficult. So it sounds like in the coming code, there'll be some resolution between at least the IECC and the IEBC. So that's hopeful, I guess.
Yeah, there is a lot of, when it comes to, that's what, if you notice in the IEBC, it, whenever, you know, how the different levels and then all the you know, trades, I guess you could say, or categories. It comes to energy efficiency, it says comply with the IECC, and then you go into the IECC and it takes you to chapter 5, which then throws you into the body of the code, depending on what it is. Now, when it came to the historical portion of the building, were you able to utilize the exemptions that existed for it? Was that where the concern came in?
Yes, and NPS had concerns and Landmark as well, just design concerns that sort of conflicted with some of that. And so it became a big negotiation process, as they typically do. But at least if the two requirements start to align, it'll be easier to have that clarity moving forward.
Yeah, I will definitely bring that when we start meeting up again about chapter 5. I'll bring that to their attention. But just keep in mind when it comes to historical buildings, and I didn't even hit on chapter 5 when it comes to that, because chapter 5 is an hour class in itself. But when you're dealing with historical projects, you know, if one of those entities and they say that you cannot change the glazing because it changes the fabric of the historicalness of it, you know, sometimes there are things that you can do. You can, when it comes to the energy code, it becomes exempt from that. If they say, no, you cannot switch out those windows to be more efficient, they have to have the same look, they have to be the same, just replace the glass, whatever the case may be. Sometimes there's certain things you can do, like, you know, install a storm window to it to kind of, you know, help with the energy efficiency, because just because it's a historical building doesn't necessarily mean you don't want it to be energy efficient. And usually if they've been around that long, they are so horribly energy inefficient that, you know, they want to do something other than, you know, shelling out $3,000 a month on, you know, trying to heat the place. And I can understand, I have a 100-year-old house that didn't, the first year I lived here, have a lick of insulation in it, and I was spending $350 a month trying to heat it, and I would only get it to 63 degrees. So, you know, I feel for them. I understand that they're trying to, you know, work within the confines, and they definitely want energy efficiency in them. They're just walking that ever so lovely tightrope to do it.
well, thanks again, Hope. Really appreciate your time today. And you'll be back with us December 2nd for another presentation. So everyone should tune in then. And next week we have our 2020 Practice and Design Conference, which is virtual this year. And we've got plenty of HSW credits to offer you on Thursday and Friday of the event. Lots of great speakers. So if you haven't already, make sure to go to aiacolorado.org and check that out and register. So yeah, hopefully we'll see you next week at the conference. And thank you again so much, Hope. Everyone have a great day.
Thank you.